Hello students, today I came up with a very important concept, mean value theorems. Many students are scared about this concept, and the moment they see the question, they leave the question, or sometimes they may not identify that the given question is an application of mean value theorem. So in this video, let us learn the mean value theorems right from the basics till advanced previous PYQs in advance. Let us learn one by one theorems, what is the meaning of that, and let's see the applications also in that. First, Rolle's theorem. What is that Rolle's theorem? States that if f is a function, real valued function, defined on a closed interval AB, such that f is continuous on closed interval and f is differentiable on open interval AB. So what is the meaning of these 2 points? F is continuous in an interval. Suppose you have a function f between the limits AB. The function is continuous, means there is no gap in the graph. It is differentiable, means it is a smooth curve between AB. So it is, if you have a graph like this, then it is not differentiable at this point. So it is a smooth curve and also continuous. So smooth curve and continuous means you may have a smooth curve like this without any sharp edges, without any sharp corners. And the third point, given that f of a and f of b are equal. So f of a and f of b are equal, and the nature of the function is continuous and differentiable. So if it starts increasing at this point, after a certain time it should come down. Okay, or you may have another possibility that suppose f of a and f of b are equal. In between you may have many possibilities of having so many turning points. You may have it. So in either of the cases, what is that thing which we can conclude? What is the minimum thing that we can conclude? Is that so between a and b there exists at least one c, because the function is initially increasing and then decreasing, initially increasing and then decreasing. Increasing in the sense f dash is positive, decreasing means f dash is negative. So the value of f dash is changing its sign from negative to positive, or positive to negative if it is an open upward. So there is a point in between a and b, let us call that c, such that the derivative of this point, the derivative of f at that point is 0. F dash of c is 0. This is what the statement of Rolle's theorem. Like that, not only one, you may have more than one c also, you may get it. So at every point of that you have a horizontal tangent. So in the statement of Rolle's theorem says that if f of a and f of b are equal and f is continuous and differentiable, then there exists at least one c. You may have more than one, you may have 2, 3, 4, 5 like that also. So this is what the statement of Rolle's theorem. And a little bit application of this one is that suppose if f is a continuous and differentiable function, and f has 3 roots, 1, 2, 3, 4, 5 roots between a and b. If f has 5 roots between a and b, between every pair of consecutive roots there exists at least one c, 1, 2, 3, 4. So if f has n real roots, then f dash will have at least n minus 1 roots. F dash will have at least n minus 1 real roots, right? And more elaborately if you talk, it is all about the root of a derivative. If your f is described as continuous and differentiable, then our discussion is for derivative of the function. Whether f dash has a root or not will be decided, okay, by the nature of the function f. It's a Rolle's theorem. It's called Rolle's theorem. Coming to next theorem, Lagrange mean value theorem. The Lagrange mean value theorem, the hypothesis is almost same. So f is continuous and differentiable, and f of a and f of b need not be equal. Between a b, function is continuous and differentiable, but f need not be equal. Suppose f of a and f of b are not equal. If they are equal, obviously it is Rolle's theorem. If they are not equal, then how would be the shape of the graph? It is continuous and differentiable. So if it start increasing, after some time it will come down, again it will come down. So it may be one of the possibility. Or here you may have more possibilities like this. Now if you join that, what are the coordinates of a comma this point a comma f of a, and this point coordinate b comma f of b, and here also a comma f of a and b comma f of b. Now if you join this starting point and ending point, okay, and you can observe that there will be at least one c, such that tangent at that point is parallel to the line joining these 2 points a and b. That means ab is a chord, so this tangent will be a tangent parallel to the chord, one of the chord, that ab. So what is it, this one, this is the derivative. What is the slope of this line? Derivative. And what is the derivative slope of the tangent at the point c, which is parallel to the line joining ab? Then what is the slope of the line joining ab? y2 minus y1 by x2 minus x1, that is what f of b minus f of a by b minus a. So the statement of the Rolle's theorem says that here there exists at least one c, here one more c also exists here, c1 and c2, their tangent at that point also parallel to the given line ab. So there exists at least one c such that derivative of c is equal to slope of the chord joining the starting point and ending point ab, that is f of b minus f of a by b minus a. So here in the second case, here you can observe that 1 2 3 4, there are 5 c's you can get, which are parallel to the chord joining ab. And a small extension of this, if you integrate on both the sides, so b minus a into integral, if you apply the limits from a to b, okay, if you apply the integration from a to b, f of a to b f dash of c is equal to b f of b minus f of a by b minus a, right? So this is f of x, f dash f of x equal to integral a to b capital F of x into b minus a. So here, so b minus a into f of c, b minus a into f of c will be equal to f of b minus f of a. What is f of b minus f of a? Integral a to b f of x, it is capital F of x, small f of x dx. So there exists a c between a b such that integral a to b f of x dx can also will be equal to b minus a times f of c. Okay, so next coming to the Cauchy's mean value theorem. In the Cauchy's mean value theorem, here f and g two functions are there, both are continuous on closed interval ab and differentiable on open interval ab, such that g of b not equal to g of a as it is in the denominator, then there exists at least once. It's an application of that Lagrange mean value theorem only. Okay, if you take like f dash of c, you know that f of b minus f of a by b minus a. G dash of c is f of g of b minus g of a by b minus a. Take the ratio of these two, you'll be getting this one. Okay, so let's move on to that one. Now let's see some questions based on these applications. Let's see, look into a question here. A function is everywhere continuous, means it is continuous on a real number, set of real numbers, and differentiable on R also, such that f dash of x is greater than 6 for all x belongs to 2, 4, and f of 2 is also given. Then which of the following options are correct? It is given that f is continuous and differentiable on the given certain interval given 2 to 4. So f is defined on that interval 2 to 4. Okay, and also it is given that f of 2 equal to minus 4, and f is continuous and differentiable, and it is given that f dash of x is always greater than or equal to 6. So by LMVT we can apply LMVT since it is continuous and differentiable, and we don't know whether f of 2 and f of 4 are equal or not, so we can apply LMVT. If they are equal, we can apply Rolle's theorem. So by LMVT, there exists a C in the interval 2 to 4 such that f dash of C is equal to f of b minus f of a, f of 4 minus f of 2 by 4 minus 2. And it is mentioned that f dash of x is always greater than or equal to 6. So this will also be greater than or equal to 6. Now, the value of f of 2, we know that it is given minus 4. So f of 4 minus of minus 4 plus 4 whole divided by 2 greater than or equal to 6. That means f of 4 is greater than or equal to 12 minus 4, 8. So it is greater than or equal to 8. So option B is correct. So generally these applications in the question, they won't mention that you have to apply Rolle's theorem or Lagrange theorem. Based on the hypothesis, we have to go with it. Most of the cases, whenever they do talk about the inequality or f of x lie between the particular values or like that, you must go with the mean value theorems. One more question. Here it is, there are two functions f and g, and f of 0 is 0 given, f of 0, g of 0 is 0 given, f of 1 is 6 given, and there exists a real number c in the interval 0 to 1 such that f dash of c equal to 2 g dash of c. It is what information given. Then we need to find out the value of g of 1 here. So in these cases, we have to choose a new functions. Let us choose a new function h of x as f of x minus 2g of x. Let us choose f of x as f of x minus 2g of x. And already it is mentioned that, then what about the value of h of 0? H of 0 will be, f of 0 is 0, g of 0 is 0 as it is given, so h of 0 will be 0. And also h of c, let us talk about h of c. H of c is equal to f of c minus 2g of c. Okay, they have given f dash of c minus g dash of c are equal. That means the derivative, let us talk about the derivative of the function h dash of x equal to f dash of x minus 2 times of g dash of x. Since f and g are differentiable, h is also differentiable. So now h dash of c, if you calculate, h dash of c will be f dash of c minus 2g dash of c, which is 0. So h dash of c value we are getting 0. And if you apply LMVT for that one. H of 1, let us calculate H of 1. If you calculate H of 1, that is f of 1 minus 2 times of g of 1. Okay, so f of 1 is given 6 minus 2 times of g of 1. So since h is continuous and differentiable, we can apply LMVT, okay, LMVT on interval 0 to 1 for h of x. Then you will be getting h dash of c, there exists a c, that c only it is given 0, equal to h of 1 minus h of 0 by 1 minus 0. So what is h dash of c? H dash of c value is given 0 and h of 1 value is 6 minus 2 times of g of 1, and h of 0 is given 0 by 1. So g of 1 value is 3. So g of 1 value is 3. This is another way we can apply this mean value theorems. Let's look into one more interesting question. Here different integration is given. Limits are from 0 to 1. And RHS, this is different integration of the same expression, is equal to different integration from 0 to 2. So integral 0 to 1 some function h of x is same as integral 0 to 2 some function h of x. What is the meaning of this? You can rewrite this one as 0 to 1 plus 1 to 2. So 0 to 1 get cancelled. So what is the meaning of this? Integral 1 to 2, that h of x must be 0. Okay, so what is integral 1 to 2 h of x? That means 1 to 2, what is h of x here? 1 plus cos square of x into ax square plus bx plus c dx, now equal to 0. Whenever different integration value is 0, that is what is the meaning of that? Here whenever that between the limits 1 to between the limits a to b, if that different integration is 0, means some part of the graph is positive and some part is negative, and there are equal amount of areas. You will have positive area, negative area, they get cancelled and you are getting 0. The meaning that there exists at least one c says that the graph intersect x-axis at some point between AB. So here if you observe that 1 plus cos square x can never be 0 at any value of x. Okay, cos square x, so it can never be negative. So only the possibility that this can be 0. This can be 0 at what point? Between the two limits AB. What are that AB here? 1 and 2. So ax square plus bx plus c equal to 0 has a root. For sure it has a root between 1 and 2. Okay, if it is between 1 and 2, obviously, okay, it is between 0 to 2. And whether can we say that double root is there, means two roots are there, we cannot decide. One root for sure you will be having between AB. Where two roots maybe there are not, we cannot know that. And even option D is wrong, because the root we got it between 1 and 2, not between 0 and 1. Hope you all got the point. So if required, you pause the video and you go back again and try the questions here. Next, one more question. Here f of x is a twice differentiable function, and also given that f double dash is greater than 0. So this will help us, okay, how it will help us in the solution will be understanding. And they gave that f of 0 and f of 2 are not equal, then which of the following is true? So when f of 0 and f of 2 not equal, we may go with the LMVT. Here in all the 4 options, you observe that there are LHS of this all 4 options is f of 0 plus f of 2, f of 0 plus f of 2, f of 0 plus f of 2. So what you can observe, so we can start our attempting the question with by defining a new function h of x as f of 0 plus f of 2 minus 2 f of x. we can define the function like this, some h of x function. And since it is continuous and differentiable, so and also what is h of 0? Here f of 0 and f of 2 are not equal. So if you define h of x like this, then h of 0 will be f of 0 minus 2f of 0, so f of 2 minus f of 0, and h of 2 will become f of 0 minus f of 2. One is the negative of other. So from these two, h of 0 into h of 2 will be a negative quantity. That means if f of 0 is h of 0 is positive, h of 2 is negative, or if h of 0 is negative, h of 2 is positive. What is the meaning of that? Since h is a continuous, f is continuous and differentiable, h will also be continuous and differentiable. So there exists a root between 0 to 2. So there exists c belongs to open 0 to 2 such that h of c becomes 0. So that is what h of c becomes 0 means f of 0 plus f of 2 equal to 2f of c. So this is the first function, right? So this is the first option. Now look into the second option. So in all options they have nicely framed in such a way that you have to apply same LMVT for different intervals. If you look at that option B, we have 0 to 1. So on the number line, so you may apply LMVT for 0 to 1 once and 1 to 2 also once. Then you can involve 0, 1 and 2, f of 0, f of 1, f of 2 values. So if you apply LMVT for 0 to 1, then what you will be getting? H dash of suppose there exists a c1 between h0 and 1, h dash of c1 equal to h of 1 minus h of 0 by 1 minus 0. So h of 1 minus h of 0, what is h of 1? F of 0 plus f of 2 minus 2f of 1, and h of 0 will be f of 0 plus f of 2 minus 2f of 0. So if you subtract, so it will be coming f 2 times f of 0 minus f of 1. So it will be 2 times f of 0 minus f of 1, and this is h dash of c, and since h dash is f double dash is positive, what is h dash of c? F of 0, so minus 2 times of f dash of c1. So because these are constants, the derivative will be 0, so it will be getting minus 2 times. So the f dash of c value is equal to f dash of c1 is equal to 2f of 0 minus f of 1. Right, so f dash of c1 is equal to, it is f of 1 minus f of 0. Okay, put this aside. Next, there exists another c2 because f(h) is continuous and differentiable on interval 1 to 2 also. So then f dash of c2 will also be f of 2 minus f of 1, it will become f dash of c. And since f double dash is positive, that implies f dash is increasing, and also c1 is less than c2 implies f dash of c1 will be obviously less than f dash of c2. So f dash of c1 is f of 1 minus f of 0, which is less than f of 2 minus f of 1. So you will be getting here 2f of 1 is less than f of 0 plus f of 2. So which is the option 2 is option C is correct. Option C is correct. Next, coming to option D. this I am leaving you as a homework. Just apply, because 0, 2 and 2 by 3 are given. So apply LMVT for the 0 to 2 by 3 and 2 by 3 to 2. So 2 parts you applied. So then you will be getting that expression also. Right? Okay. Let's look into one more question. Another interesting and surprising application of this question. Actually, here we need to compare two numbers, two real numbers. So what are the numbers? X1 and X2. X1 is 7th root of 3 plus 7th root of 9, and X2 is 7th root of 5 plus 7th root of 7. Just we need to compare these two numbers, and generally what we try to do, we try to go for approximation. But here using LMVT, because that all the elements, all four numbers are 7th roots only, so we can go with if we can define a new function f of x as x power 1 by 7. Now what are the numbers involving over here? The numbers involving over here is 3, 5, 7, 9. So you may apply LMVT for 3 to 5 interval, and again apply LMVT for 7 to 9 interval separately. So if you apply LMVT, and also if you calculate f dash, okay, so you got the value of f dash of c1. There exists some c1 or alpha 1 between alpha 3 and 5, some alpha 2 between 7 and 5. So that f dash of alpha 1 you will be getting, and f dash of alpha 2 also you will be getting, and from that you got by taking the ratio of these two, f dash of 1 and f dash of alpha 1 and f dash of alpha 2, you are getting the value more than 1. That means f dash of alpha 1 is greater than f dash of alpha 2. So just by substituting f dash of alpha and f of alpha 2, we could compare the numbers, the required one. So this is also another useful application of this LMVT. So in the question it is not mentioned, but we have to identify whenever, as and when a function is continuous and differentiable, and you need to compare the elements, inequalities you need to equally, you may go with that. One more question, it's a previous GE advanced question in 2017. Here f is a twice differentiable function, it is mentioned, and f double dash of x is greater than 0 given. That means f dash of x is increasing, and in concave up also, since f double dash is positive, and f of 1 by 2 is 1 by 2, f of 1 is 1. Since f of a and f of b are not equal, f of 1 and is not equal to f of 1 by 2, we can apply LMVT. If you apply LMVT for the interval between 1 by 2 to 1, between 1 by 2 to 1, so there exists a c between 1 and c, such that f dash of c is equal to f of 1 minus f of 1 by 2 by 1 minus 1 by 2. F of 1 is given 1, f of 1 by 2 is also given 1 by 2, so 1 minus 1 by 2, so it is 1. So there exists a value c between 1 and 2, such that f dash of c becomes 1. It's a quite simple question. Okay, so since f dash of c is going just we need to understand geometrically. At c itself f dash is increasing, so one thing is that, and f dash is increasing function. That means since c is less than 1, then f dash of c would be less than f dash of 1, and f dash of c value is 1, so 1 is less than f dash of c, f dash of 1. So f dash of 1 value is strictly greater than 1. So option C is correct. Option A would be wrong, since it is more than 1, it is also wrong, and even this is also wrong. So option C is correct. So sometimes the questions in advance also be like this. Just understand the question, you can answer it. The only twist here is that since f dash is 1 and f double dash is greater than 0 is given, we need to identify that f dash is increasing. With the help of that, we could get it is more than 1. One more question in advance let's look into that. It's given in 2015, and the question is that f and g are two functions depend on the same interval. So here f and g are two functions depend on the same function, continuous functions, and also twice differentiable functions, and the interval open -1 to 2, and the values, corresponding values are given. And here that options will give you the hint what function we have to choose. In all the four options you observe that f dash minus 3g dash. So let us choose a new function h of x as f of x minus 3 times of g of x. So if you differentiate both sides, h dash equal to f dash minus 3g dash of x will come. And everywhere intervals are given between -1 to 0, 0 to 2, like that. Okay, so what is h of -1 value? F of -1 minus 3 times of g of -1, and the f of -1 is 3 minus g of -1 is 0, so it is 3, and h of 0 will be 6 minus 3 into 1, that is also 3, and h of 2, if you calculate, that is 0 minus 3 into -1, that is also 3. So if you observe here, there are 3 reference points. Here you have -1, 0, 2. F of -1 is also 3, f of 0 is also 3, f of 2 is also 3. So you can apply LMVT for between -1 to 0 as well as 0 to 2 also. So not LMVT, rules theorem, sorry, because f of h of 0, h of -1 equal to h of 0, so there exists an element, some alpha between those two, such that h dash of alpha will be 0. Similarly, since h of 0 is equal to h of 2, there exists another element, is, let's say that it is beta, that h dash of beta will also be 0. So there is a root for h dash between -1 to 0. Okay, what is h dash? H dash is this expression only. So h dash equal to 0 has exactly in the first option they told 3 roots. There is no guarantee that 3 will be there. We know that exactly one root between -1 to 0 and one root between 0 to 1. Only that information we have it. So option B would be correct, has only exactly one root. Okay, between -1 to 0. Okay, generally here what is that rules theorem says that at least one real root, but they told here exactly one root. So for that you need to understand the sign of h dash. If you observe that f dash minus f minus 3z whole double dash never becomes 0, that means h double dash of x is never, it becomes 0. It never becomes 0 means either h dash is positive throughout, or h double dash is positive, or h double dash is negative. That means h dash is either increasing or h dash is either decreasing. And if you so as here h double dash is either greater than 0 or less than 0, only one will happen. That means it's a monotonic. H dash is monotonic. So since h dash is monotonic, so there will not be any other root between those two. Exactly one root between -1 to 0 and one root between 0 to 2. So B is correct, C is correct. 2 solutions, it is wrong. Here also given 2 solutions, wrong. It is wrong. So option B and C are correct options. This way you can once you go through this same video, the information and the questions, and you can work on the same concept for some more questions. So definitely it will give you a good command on the particularly mean value theorems. Hope this information will help you. So all the best.